Hello, you're welcome to my presentation on Chapter 13, Annuities and Sinking Funds. Now, this is a part 2 of my discussion on the chapter. Now, in part 1, I did look at the conceptual uh, overview of the chapter, and in this part, I'll be looking at a number of problems that we can solve together. So again, if you remember what we said in chapter 13, we are looking at, for example, the present value and the future value, but in this case is the present value and future value of annuities. In our previous chapter, we were looking at present value and future value of a single amount. Again, if you remember, we did look at different types of tables. But in this chapter, our focus is on an annuity table, I would call the ordinary annuity table, and also to look at the present value of an annuity. And then, of course, is also to look at the sinking fund table. Now, the sinking fund table is something new, but of course, the purpose of this table, it gives us the table factors that we use to determine, for example, if we have to look at what the payment or what the annuity should look like. For example, if you want to buy an equipment in the future and you know what the cost will look like, and you want to start setting aside an equal amount of money so that you have enough funds to buy an equipment in the future, or maybe to retire a debt in the future, then of course this table is going to be relevant. But I'm also going to show you a different way that you can find, or you could estimate, or you could check, verify your answers by looking at a different approach. So let's look at the first problem uh, on how we apply this concept as we saw. So in this case, you've been told Joseph Company borrowed money that must be repaid in 20 years. So money has been borrowed and the money has to be paid in 20 years. The company wants to make sure the loan will be repaid at the end of year 20. So we're assuming that this loan has to be paid in lump sum, that is including the interest and the principal at the end of year 20. So in this case, the investment is 12,500 at the end of each year, and a 12% compounded on an annual basis. So what is the amount of the original loan? Now I like to use the timeline. Again, I told you when it comes to this time value of money problems, the best thing to do is to use to draw a timeline. So I'm going to draw one, and let's just to give us a bigger picture of what you're doing. So in this example, assuming this is year 1, year 2, year 3, all the way. So at the end of year 1, you invest 12,500. Year 2, you invest 12,500, and you continue all the way to year 20. So here is times 0, here is 20, and you have invested 12,500. So this is the investment each year. So again, you want to make sure that, remember, the question is saying you want to make sure that you have enough funds at the end of year 20 so that you can use those funds and repay the loan. So again, you can look at this problem from two perspectives, and you have to make some assumptions. And the assumption I'm making here is the original loan amount we're being asked, because that's what you end up borrowing, I'm going to assume that is supposed to be the present value, because I don't want to assume this is the future value. No, you borrow less, but you pay with 12,000 at the end, you'll have paid more. Or you could assume the future value of this annuity payment becomes the money you must accumulate and be able to pay. So you'll assume that the future value of this series of payments is how much you need to pay off the loan when the loan matures or when you get to the 20th year. So depending on how you look at it, is could be an application of a future value, or could be an application of present value, or could be an application of both. So to look at the future value only, let's say this is the future value, the accumulation. How much do you need to accumulate by the 20th year so that you can pay off this loan? In that case, what we are looking at is the future value of annuity payments. So the future value of the annuity payments, all these payments, 12,500 each year for 20 years at 12%, and where N is 20. So the future value of this will be the annuity payments times the future value interest factor of the annuity. Now we know that the future value, now the annuity payment is 12,500. What about the future value interest factor? So we have to go to the table and determine what the future value interest factor for the annuity will be, where of course N is 20 and I or rate is 12%. So it means you have to go to a future value table, and this is the table. Unfortunately, I don't have the 12%, but 12% will be somewhere there. And I don't have 15, but you keep on going. Again, if you have a full, this is just a partial table, but if you have a full table, you should have 20, and then you should have 12%, and you should have a factor there. And simply put, I can even show you how all these factors are derived. So if you're looking at the future value table, then we know that the future value uh, of an annuity, the future value, that factor, again, mathematically, it is basically 1 plus I, that's the rate, raised to n minus 1, and you divide everything with I. Again, if you apply this, we know that uh, our I is 12%, so we're talking of 1 plus 0.12, and you raise this to n is 20, and then you subtract 1 and you divide the entire product with I, and your I is 12%. Now, if you apply this, just to give you, I just want to show you how those factors are derived. It's easy to get to get this from the table, but I just want to show you how those values are derived. For in the case of 12% and 20, so we have 1.12, and we raise this to 20, we get 9.6463, and you subtract 1, you have 8.6463. So in this case, then you have 8.6463 as a numerator, and you divide this with 0.12, then you get a value of 72.0524. So this is the table factor that is supposed to represent the 12% and a period of 20. Again, if you go into the table, if you have access to the table, you'll see that value to be 72.0524. Exactly, that's will be the value. So then you'll multiply this with the future value interest factor of 72.0524. So multiplication this with 12,500, we get a future value of 900,655.5305. So this is how much it needs to be accumulated. So in other words, by the 20th year, you should have 900,655 and 53 cents to pay off this loan. So again, is that the original amount of the loan? Most likely I would say no, because this is how much you need to have. So how much they borrowed probably will be something of a present value, will be a present value of this amount. So the present value of this amount at times zero will say, if this is the future value or what you need to have to pay off the loan, then the present value will be you'll take the future value and then you divide this with the present value interest factor. So in this case, our present value interest factor, I think for a single amount where n is 20 and the rate is 12%, so uh, you'll take 900,655.5305 times the present value interest factor of $1. That's a single amount. In this example, or if you go into the table to find the present value of $1 for 12% and for 20 years, you'll find this to be 0.10367. So you take 900,000 times 0.10367. Now, if you multiply that with 900,655.5305, what you end up getting is a value of 93,370.9589. So this is what I can say is the original amount, or is what was borrowed. This is how much was borrowed at the beginning at time zero, but in terms of how much they need to have to pay off this loan, they need to have 900,655 to pay this loan in 20 years time. So again, it's more confusing, but again, the original amount, I'll reflect this to be the present value, but how much needs to be accumulated to pay off this loan will be the 900,655.5305. Again, in this example, we have applied two things. One is how to find the future value of an ordinary annuity, and also is how we apply the present value of a single amount, which is a different table, to find the present value of the 900,655. The other approach again could be, instead of finding the present value of a single amount, will be to find the present value of all these annuity payments. So find the present value of all these payments here. That will be, again, will be the same answer, of course, you're going to get here. And then if you look for how much needs to be accumulated, then you can also then find the future value of the single amount, which is 93,370, and you find that to be again 900,000 and 655 and 53 cents. So either way, you'll arrive at the same answers. In the second problem, is we have been given that on Joe Martin's graduation from college, Joe uncle promised him a gift of $12,000 in cash or $900 every quarter for the next 4 years. Again, if I draw a timeline, you're being promised that when you graduate, you're being promised that you either get $12,000 at the time you graduate is one option, or you're being promised that you get to every quarter you get $900. So year one, year two, year three, and year four. But every quarter you get 900, 900, 900, and 900. So in a year, again, we have four quarters in a year. The same thing for year one, you get the same thing. In second year, the same. So you get $900 every quarter. So this is how much money you'll be receiving. Or you get an option of getting $12,000 again at the time of graduation. So if the money could be invested at 8% compounded quarterly, which offer is better for you? Again, you have to make an assumption here. And the assumption I'm going to make here is the $12,000 is what you're going to receive again in future at the time you graduate. You're given that amount. Or you say, I don't want this, I will take the second option of getting $900 every quarter for the next 4 years. So, given that scenario, then, which offer are you going to get? So, in other words, what we're trying to do here is we're basically comparing the future value, because the 12,000 in the future, in 4 years' time, is the future value. And we need to determine, of course, the future value of the annuity payments, which in this case is the $900. So what you'll do is to determine the future value, we'll take the payment. So the future value of the annuity will be, you'll take the annuity payments times the future value interest factor of an ordinary annuity. In this example, we know that the amount or the annuity is 900. The future value of interest factor of the ordinary annuity, where, of course, here we talk about 4 years, and we have four periods in a year. So we're talking about 16 periods. So in this case, our N is 16, and our rate, our I, is 8% per year, but this is per quarter. So per period, we're talking of 2%. So N is 16 and I is 2. So if you go to the table, you can find the future value of the ordinary annuity, where, again, this is the table you need to go to. It's the same table. I don't have 16, but it's going to be 16 value and 2%. So it'll be something there. Again, if I go to my table and look at 2% and I look at 16, I get I find the future value interest factor to be 18.6393. So if you multiply this, 18.6393 times 900, you find this to be 16,775 and 37 cents. So this is the future value of the annuity payments, and this is the future value for the cash that you end up receiving if you don't choose the option of a series of payments. So if you compare the two, of course, you'll choose the one that is more, and the greater one is the 16,775 and 37 cents. So you'll choose the idea of getting $900 every month, and then if you invest this money in a bank, then you'll end up having or accumulating 16,775, which is more than the $12,000. So in that case, you'll choose the second option. Again, we're assuming the $12,000 is to be received at the end of 4 years, or you get $900 every quarter for the next 4 years. The other problem, which is the last problem, is you've been given a local Dunkin' Donuts franchise must buy a new equipment in 5 years, and the cost of the equipment is $88,000. Again, if I do my timeline, in this example, we know that you need to accumulate 88,000 in the next 5 years. So in the next 5 years, you need to have $88,000 that you need to buy an equipment. So the question here is, how much are you going to set aside in a bank that is going to earn you 8% interest every quarter, so that you have $88,000 that you can use to buy the equipment? So if you think about it, this represents a future value. So you could either, again, this is a sinking fund problem. So there are two ways to do it. So one is to determine what our N is and determine what our I is. Now it's 8% per year, and this is to be deposited on a quarterly basis. So our I will be 8 divided by 4, which is 2% per period. And we're talking about 5 years, so the total number of periods is 5 times how many periods do you have in a year? We have 4 periods in a year. So in this case, our total periods is 20. So N is 20 and I is 2%. So the question will be, then how much will be the quarterly payment? So how much should that payment be, so that again you are able to save enough money to buy the equipment? So mathematically, let's think about this. We know that the future value of the annuity is equals to, we take the annuity payments times the future value interest factor of an ordinary annuity. Now we can determine this from the table. So we can find this from the table. This is given to us, and this is given to us as $88,000. So this is one way to look at it. And the future value interest factor of an ordinary annuity, where N is 20 and the rate is 2%, is 24.2974. So this is the future value interest factor. And therefore, if you think about it, just to test to see where our answer should fall or should be close to, then our payments, the annuity should be 88,000 divided by 24 point, sorry, that should be 24.2974. Now if you do this, I'm going to show you this in two ways. So if you take 88,000, it's going to be close, divided by 24.2974. This will give you a value of $3,680. and 21 and 78.67. So this is how much you need to set aside. In other words, you need to deposit 3,621 and 79 cents for each quarter. So this will accumulate to 88,000 you need in the next 5 years. So again, I just did this from a mathematical point of view. Otherwise, what you need to do is to go to the table and determine what our sinking fund is. So you find where the sinking fund is, where N is 20 and 2%. Again, you find what 20 represents and 2 represents. And therefore, you'll take this value and you'll multiply that value with the $88,000, and that will give you what the payment will look like. So that's what basically the sinking fund table is. But what I did was just to show you the same, using the same concept of the future value interest factor as we saw in the chapter. So I hope this information helps, and do more practice on these problems, and feel free to let me know if you have any questions or any concerns, or if there is any problem from the homework that needs my attention. I'll be happy to help, but I'll be looking forward to the next chapter, which will be chapter 14. Thank you.